The AHRS uses internal gyros and accelerometers for attitude but requires aiding data from other sensors for accuracy and drift correction. Key aiding sensors include satellite navigation receivers providing position and ground track, magnetometers providing magnetic heading, and the air data system providing airspeed, altitude, and vertical speed. The availability and validity of information on the PFD directly depend on the health of these sensors. If the satellite signal is lost, the system loses its primary position reference. However, if the magnetometer and the air data systems are still functioning, the AHRS can typically continue to provide reliable attitude and magnetic heading information. Airspeed, altitude, and vertical speed would also remain valid. Conversely, if the magnetometers fail, the system loses its source of magnetic heading. This will usually be indicated by a heading flag or red axis over the heading display. If satellite navigation is still available, the AHRS might be able to calculate and display ground track, but magnetic heading becomes unreliable. Attitude, airspeed, altitude, and vertical speed should remain valid if air data is available. A failure of the air data system, for example due to pitot tube blockage, results in unreliable airspeed, altitude, and vertical speed indications, typically flagged with a red axis. Attitude and heading might remain valid if the AHRS has sufficient aiding from satellite navigation and the magnetometers. The situation becomes more complex with multiple failures. For instance, if both the magnetometers and air data fail, even with satellite navigation available, you lose reliable heading, airspeed, altitude, and vertical speed. The AHRS might provide attitude based purely on satellite navigation and inertial sensors, but its accuracy would degrade. If satellite navigation fails in addition to magnetometers and/or air data failures, the AHRS loses significant aiding data. While it attempts to maintain attitude using its internal sensors, drift can become significant, making the attitude indication less reliable over time. In such scenarios, constant cross-reference to standby instruments becomes absolutely critical for safe flight.